simplify each of the following expressions without a calculator. Okay, I won't use a calculator then. But on this one, I mean, look, remember, if you want to see this as -5, that's a -5 plus -13, you could. Right, that's what we learned last time. You can change subtraction expressions into addition if you'd like. Or you can change addition expressions into subtraction as well. Now, whether you understand it better one way or the other is really up to you. So if you looked at this and you're like in red, you got 5 negatives and then you add another 13 negatives, therefore you know it's more negative. 5 plus 13 is 18, that's fine. Whether you say -5 and then you go to the left 13 in the original problem, that's fine as well. You're still going to end up with the same answer on that one, okay? Now this next one, -6 minus -8, I don't like to see minus negatives, I like to see plus. I'll change that to a big fat plus sign, so now it would read to me -6 plus 8. Now we're combining negatives and positives on this thing, which means that the 6 negatives are going to cancel out 6 of the 8 positives, which means you're going to end up with 2 positives remaining on that one, okay? And then number 3, again, if you'd like to see that as a -9 minus 10, you could. It's really up to you. You should get the same answer either way. 9 negatives and 10 negatives combined to be 19 negatives. We can show number 2 with the negative thing, right? So I'll rewrite it. It's -6 minus -8, right? Now on a number line, I'd say, you know what, look, I'm going to start at -6, which is over here to the left. Okay, and 0 would be over here. 1, 2, 3, 4, 5. So that's -6 right there. And this is 0 right up in here. Well, the thing about subtracting negatives is the negative direction is to the left. That's true. However, subtracting negatives really means that we're going to go in the opposite direction. So even though we're starting at -6 here, we're going in the opposite direction of negative, which is to the right. That's the positive direction. And again, that's really why we can show this as a plus sign right there. Then how far? 8. 1, 2, 3, 4, 5, 6, 7, 8. Which does end us up at 2. If you thought about this more in terms of the hot and cold cubes, it'd be like, look, you got 6 cold cubes in there, and then you're going to take out 8 cold cubes. You know what I'm saying? Like, what is the change in temperature? Well, you took out 8 cold ones. So even though you put in 6, by taking out 8 of them, you would have increased the temperature by 2 degrees. Or our favorite word problems. Courtney has $45 in her bank account. I may need more space for this. After she went shopping, she looked at her account again and she had -$12. Oh my gosh. How much did she spend shopping? Okay. Well, look, she started with $45 in her bank account, and yeah, that was positive right there. But then suddenly, she ends up in the negatives. -$12, right? So how much did she spend? That means we're going to, no. It's really asking what the difference between these two is. In fact, let me show this in a little bit more precise way. So, to put this more precisely, I'm going to use a vertical number line because I think it's a little bit better demonstration of it. And if I put 0 here, then positives is towards the top. We'll go up to 45 right there. And then I'll say that -12 is about right here. And I know that's not proportional, but I don't really give a crap. So, on this one, I say, well, if she went from 45 down to 12, how much did she spend? Well, she would have had to spend $45 just to get down to 0, right? But then she's got to spend another $12 if she was down to get down to -$12. So to figure out this out, how much she spent, would just add the two values there in green and orange, and we'd see that she spent $57. And again, I don't need to put this as negative, but I will describe it as spent money. So spent $57. And yes, if you guys want to be more precise and say Courtney spends $57, that's fine. But the answer is still the same. Alright, here's our objective. I can multiply and divide integers. Just take a minute and copy that down, and we'll start the lesson, alright? But, you know, just remember that. I mean, this is our objective. We need to learn this by the end of the lesson, because if we haven't, then we may be in a little trouble. Sometimes the chefs wanted to raise or lower the temperature by a large amount, but did not want to put the cubes into the cauldron one at a time. So for large jumps in temperature, they would put in or take out bunches of cubes. For instance, if the chefs wanted to raise the temperature 100 degrees, then they might toss 5 bunches of 20 hot cubes in the cauldron instead of 100 cubes one at a time. This saves a lot of time because they could have assistant chefs do the bunchings. When the chefs used bunches of cubes to change the temperature, they used a multiplication sign to record their activity. For example, to describe tossing 5 bunches of 20 hot cubes each into the cauldron, they would write 5 times 20 equals 100, where 5 meant that 5 bunches were being added, and the 20 showed that there were 20 hot cubes in each bunch. The chefs could also change the temperature by removing bunches. For example, if they removed 3 bunches of 5 hot cubes each, the result was to lower the temperature 15 degrees. Because each time a bunch of 5 hot cubes was removed, the temperature went down 5 degrees, and to record this change, they would write -3 times 5 equals -15, where the -3 meant that 3 bunches of cubes were being removed, and the 5 shows that they were removing the 5 hot cubes in each bunch. It's a good reminder, if you take out hot cubes, it's the same thing as lowering the temperature. It would be the same as putting in cold cubes. Or if you take out cold cubes, it's the same thing as raising the temperature. And that's a really good question, because right now we're only looking at 2 numbers at a time, right? Well, -3 times 5 is like, well, that's really nice, and it feels good inside. It feels almost elementary, you know what I'm saying? But we're going to expand these out so that you should be able to do it with any number of integers that are being multiplied. Each of the problems below describes an action by the chefs. Figure out how the temperature would change overall in each of these situations and write an equation to describe the action and the overall result. All right, there's 3 problems for you guys. Take a minute, well, 2 minutes, and see if you can write these to describe what's going on here in an equation, and then figure out how what the overall result would be. Okay? 1 minute, well, 2 minutes. 2 minutes, go. So part A, 2 bunches of 6 cold cubes were added. Okay, so since we're adding bunches and there's 6 cold cubes, let's see, so we need the expression for this, right? So it's 2 bunches of 6, but they're cold cubes, so we're going to put a negative on that. And this would read, by the way, you guys, 2 times -6. So remember, we don't use x's for multiplication. We don't have to use the dot either if we're using parentheses like this. And what the result ends up being on this one is it would have reduced the temperature by 12 degrees here, which is why we show negative. Yeah, it's not required that you show the multiplication like I do. Like if you want to show the dot, that's fine. Now do be careful though, because if you were to write this in this way, 2 times -6, it's like, well, is that a minus sign or a negative? So I mean, it may be helpful to just put parentheses around it anyways, okay? Just no x's, man. So next up, 4 bunches of 7 hot cubes were added. Yeah, 7 hot cubes were removed on that, okay? So there's still 7 hot cubes, so that's still a 7 right there. But since it was 4 bunches and they were removed, we're going to show it as a -4 right there, because since we're removing since we're removing hot cubes, it really is going to have the effect of reducing the temperature, in this case by about 28 degrees there, okay? And then the next one, 3 bunches of 6 cold cubes were removed. And by the way, you guys noticed I made that mistake of just not reading the whole problem. I do that from time to time, which I recommend you not do. Make sure you actually are reading the whole stinking problem, right? So on this one, it says it's 3 bunches, and it did say they're removed, so it's going to be negative right there. And this one's going to be 6 cold cubes. So as an expression, it would look like this. I should have used purple because that's our negative value. And when we get a result out of this, since we're removing cold cubes, we know it's going to end up being positive, and then 3 times 6 is 18 right there. So it would have increased the temperature by 18 degrees. Good question. But let's analyze that even further, because if we can remember what multiplication is, and I think we talked about it a little bit in our first lesson, right, then hopefully it will kind of help us make sense why that is a -12 on part A. Well, it says that they got 2 bunches of 6 cold cubes were added, right? So that means you got 6 cold cubes here and then another 6 cold cubes there, but we're adding these together. Now, you know, just to clarify, that's adding a negative. I can put that in parentheses. And so hopefully this helps us to see that, like if we used a diagram even, 1, 2, 3, 4, 5, 6, there's 6 cold cubes. And then you'd have another 6 cold cubes. When you combine that all together, it is 12, but because they were cold, it would be a negative on that. So yeah, on part C, right? Yeah, you got 3 bunches of 6 cold cubes. Well, cold cubes is, I got purple here and then the negative thing, right? But since they're being removed, it is subtraction of those. And, well, even the first 6, we're getting rid of that. So we'd have to show that as even like a double negative kind of thing, all right? In any case, it becomes plus and plus and plus, which is why it's 18. Number 2, describe the action involving hot or cold cubes that is represented by each of the following arithmetic expressions and state how the temperature would change overall. All right, guys, take 2 minutes and see if you can write those out and then solve them as well. Okay, 2 minutes, go. Well, let's go ahead and describe both of these right here, and I'll go ahead and write it in. I'll write it in what I got. Yours should be pretty similar, but it shouldn't be way off on this, okay? So the first thing I see on this one is it's a negative 10. So that's the same as removing. So I'm going to remove, I'm going to remove 10 groups. You could say bunches if you wanted, but I'm going to remove 10 groups of, and then the 5 right there is negative, so it has to be cold. So 10 groups of cold, 5 cold cubes. 5 cold cubes. Bam, and for the result on this one, so since we're removing negative cubes on this, I know it's going to end up being positive. 10 times 5 is going to be 50. This would raise the temperature by 50 degrees on that. On this next one, since that 4 is positive, I guess they've shown it's positive, and that's fine. We know that it's adding, so we're going to add, and it's 4, so we'll say 4 groups. 4 groups. And we got 8, but the 8 is negative, so it's 4 groups of 8, but the negative is going to make that cold. 8 cold cubes. Alright, so since we're adding negative cubes, or cold cubes, we know the result must be negative. Just got to figure out how much. 4 times 8, 4 groups of 8 is 32. So this one would drop the temperature by 32 degrees. Alright, I'll go ahead and see if I can model this thing. There we go, I was able to produce 1 group of 8, but we need 4 of them, right? And yeah, those are negative, by the way, because they're all shaded in. And then seeing that as 4 groups of those negative 8s, this would complete it, and we can see clearly that there's 32 of them, and they would all be negative right there. Well, I guess this is what it said right there. The multiplicand tells you how many groups the multiplier of the multiplier there are. Okay. So, yeah, let's show this on the number line. I'll just do it real quick so that it, you can just be out of the way. So this would be, I would say this is 3 groups of negative 2, right? Now, with this method, you kind of have to start at 0 all the time. And it's 3 groups of negative 2. So there's 1 group of negative 2. There's 2 groups of negative 2. 3 groups of negative 2. Where do you end? Negative 6. All right. And if you'd like to show it with the little rainbow things, because rainbows are pretty, you're welcome to do that as well. All right, write rules that might be used to multiply integers. How could these same rules be used to divide integers? Why? Use a different model to demonstrate each of the following. I'm going to read the answers anyways, whether you like it or not. But the first one says a negative times a positive is a negative, and a negative times a negative is a positive. I hate that rule. I hate both those rules. And I'll explain why here in a second. But the second part, yeah, they're the same. How could these rules be used to divide integers? The same. Division is the same as multiplication of fractions, which we'll get into a little bit more detail later on. But yeah, there's the modeling of those 3 problems there. But that brings us to a multiplication table. This says chart, whatever. You guys, I think you've done it before, but probably up to like 10 or 25 or something like that. But this one, you can see that we got zeros, and it goes into the negatives as well. I'm going to give you guys 2 minutes to see if you can fill this out, and then we'll look at what it should look like filled out. Okay, 2 minutes, go! Well, here is the chart like it should look. And we used that purplish color for positives, I guess. That seems backwards. And then I guess the reds were negatives, which seems backwards because red was hot. So you can see in the top right corner, all of those are positive, and then the bottom left as well. Top left is all negatives, and bottom left, bottom right as well. Well, that's because, again, when you have negatives and positives together, it makes negatives, and then negatives and negatives is positives. You know, but positives and negatives are negatives, and positives are positives. That's a lot of positives and negatives. But in any case, I know I said though, I feel like they came out right. You didn't have to understand that because we're going to take this an extra step further, okay? So here's what I'm talking about, is now that we've taken care of all the kiddie stuff, let's start doing real stuff. Let's get it real, okay? Now this is all multiplication between each of these factors. What we want you to do is figure out what the product is. 1 minute, go! Well, there's a different way to go about this, and I like this way much better. Because you could go from this left to right, and it's like, do that sort of operations, and I feel good about it. It's true. I just kind of feel like it takes a long time, right? Well, the other way to do it is to look at this. And what I'm going to do is just figure out how many negatives there are. And I got 1 there, 2, 3, 4, 5, 6, 7, 8, 9, 10 negatives, okay? Now you could look at it and be like, well, a negative times a negative is a positive, times a negative is a negative, times a negative is a positive, and that'd be a huge waste of time, okay? And you probably wouldn't like it, and you'd hate yourself for doing it, okay? But by counting 10, as long as I got that right, and I mean, my handwriting sucks, but in any case, I see there's 10 negatives. Well, 10 is even, therefore I know that the answer is a positive, and I can write a positive on this. Which means now I get to ignore all the negatives, which I feel really good about, okay? The last thing I really need to do is the multiplication, but I see there's a lot of multiplication by ones. Multiplying by 1 is so great. As math people, if you can multiply by 1 all the time, math people just love it so much. Well, the reason why I say that is because when you multiply by 1, it's the identity property of multiplication, so I'll just get rid of them, okay? Now I'm looking at just straight multiplication between the 4 and the 2, which is 8, and then 8 times 5 is 40, so the final answer is positive 40, done. So the thing that you should notice, not only from the problem we just did, but also from the that table thing, is when you're multiplying with negatives, there's really only 3 parts to it. You got to count how many negatives there are. And that last one I counted 10. Then the second part, is that even or odd? 10 is even. So part 3 is, well, if there's an even number of negatives being multiplied, then I know the answer is a positive. Now if there were an odd number of negatives, because some of you guys asked, then I would know that the answer is a negative. It's that easy to figure out. Now the reason why we do this as well is just to figure out. This only tells us if the answer, the product, or the quotient for that matter, is a positive or negative. That's the only thing it does. You still have to do the multiplication after that, okay? But if there's an even number of negatives, it's a positive. If there's an odd number of negatives, the answer is a negative. It's that easy, guys. Now that brings us to the objective. I can multiply and divide integers. Remember, we should know how to multiply by now. However, the same rules that we just went over for multiplication apply to division of integers as well. So you would look at division, and once you've simplified numerators and denominators, then you're looking at, well, is there an even number of negatives or an odd number of negatives, which would produce different types of answers. And remember, the thing about doing that is so that we can know if the answer is positive or negative. We still have to do the calculation afterwards.